lab partner. You got that done? Good, good, good. I got rid of the other stuff. At this point, we don't need that anymore. Just remember what we are trying to do. We rewrite that is we're trying to figure out the mass using Newton's second law. If Newton's second law is true, we can do that. So there's my setup if I'm going to use Newton's second law. So I'm going to graph this data. That calculation table becomes the table that you're going to use to graph. You are going to need some graph paper. Hand draw this bad Larry. You're going to want to draw the best fit line. Actually, on this one, no, you don't have to hand draw this. This should be a straight line. Oops, I told you that. This should be a straight line when you graph it. So if you want to use a program to graph it, put the best fit line, that's fine. But you do have to use the 0, 0 point. You do have to include that as one of your data pieces. So we have nine trials, 9 x, y's. You're going to want to put the acceleration as your x and force of weight as your y. There are 9 of them here. The 10th one is 0, 0. That is a point. And on our graph, here's my graph, I am going to put that 0, 0 point as one of my points. If I don't do that, you're going to probably end up drawing a line into either the y or the x-axis. And you can't do that because it doesn't make any sense. So the 0, 0 point says that if I have 0 force, I'll have 0 acceleration. That's true. It's a point. You have to include it. Okay, so let's go ahead. We're going to graph your data. You're going to take your graph paper. Remember, using graph paper, use as much of the graph paper as possible. It'll lessen your error if you make one. Okay, small errors on big graphs are small. Small errors on small graphs are big. So use the graph paper. I am not going to tell you what scale to use. Okay, I got you coffee, donuts, and pillows. I did the lab. What else do you want from me? Okay, you pick the scale that you're going to use, but do put on the y-axis F. On the x-axis, you're going to put A. Got to do that, and I'll show you why in a minute. You decide. Figure it out. Look at your data points. I do know this. Okay, I know that, like, for the acceleration, the fastest acceleration is 0.564. So maybe I want my graph for the acceleration on the x-axis to go out to 0.6. 0.6. You know, maybe, I don't know, every 4 lines, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, something like that. And then here, you go ahead and figure it out, though. This is, the highest value is 0.196, or 0.2. So you're going to have to make a scale that goes from 0 up to 0.2 to include all the data. You go ahead and do that. I have faith in you in figuring that out. All right, so once I get this done, I'm just going to, I don't have graph paper here. I'm just going to eyeball this bad Larry. But, all right, I know 0, 0 has got to be a point. And this one is, let's take this one. So y-axis, this is F. And x-axis, this is A. All right, so we'll graph some points. For 0.6, I'll say like that's point, oh, no, 0.2, 0.2, and 0.6. Maybe that's 0.2 and that's 0.6. So I got a point like out here. For the second one, 0.518. So if that was 0.6 and that was 0.8, so 0.5 maybe is like here, and 0.17 is like here. All right, maybe something like that. And this last point here, down here, 0.9. Of course, you're going to have more points. You've done all the data. You make sure you put all those points up. All right, and get them all on your graph. So down here I have maybe 0.039. So if this is, I guess that's 239, maybe here, 0.08 is not even 0.1, so it might be something like that. I know that ended up being like looking pretty straight, like a straight, and it should be a straight line. It should be a straight line. But I don't know where your data points are going to fall, and of course I just eyeballed that, and that doesn't mean that's accurate. So let's say that you get your data points, you put them on there, and they look something like this. You know, you got one here, 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 and I don't know, here. Okay, so what do? Draw the best fit line. Best fit, do not connect the dots. 9, do not connect dots. You need a line that best fits to represent the data, so you just do the best you can. Do the best you can, all right? Now, you might have enough data points where you can go ahead and figure it out in a graphing calculator what that line should be. Do it, that's fine. But you have to draw it in and make sure you use a 0, 0 point. If you have data points which are coming in like this, Do not put that data point, do not extend that line to that point. It has to go through that 0, 0. So through the 0, 0 point, I might have something like that, and it goes up like that, and that's my best fit line, and I have a nice straight line there. Okay? So make a straight line out of it. Draw the best fit line you can. I have not done this out. I don't know how it comes out. Hopefully, you and I did a decent job where we'll be able to get a relatively small percent error. Now that, like I said, going back to why percent error, because we had this pulley which had an okay amount of friction. Not a little, not a lot, okay. So I know the mass should come out to be something greater than 0.3. How are we going to figure that out? Come on, some of you know the slope. You see it, don't you? You see it now. Rise over run. Rise over run. Y over X. Look at, rise over run is going to give us our mass. The slope of this will give us the mass of the air current. Oh, pumped. All right, so we will take the slope of this. Now this is a straight line that goes right to the 0, 0 point. Use one of the points as 0, 0. It's part of the line. And then just go and look in your graph paper and try to pick one other point that, you know, maybe it's really close to where the graph paper cross lines are. And that's probably what I would do. It's the easiest thing to do. And then find the y for that, find the x for that. And if you're using 0, 0, that's your other point. All you have to do is take that point and divide it by that point. So look up here, get the number, look down here, get the number, divide, and you have the mass of the air current. All right. Again, haven't done it. I'm predicting it's going to be greater than 0.3, but less than 0.4. We should be in the 0.3 blah blah range. And once you get that, do that calculation right here. Show it to me right in the slope. You can put that right in this, the slope calculation right in the graph. Put it right on there. And last but not least, do a percent error. Let's see what we get for a percent error. I would say, hopefully you want to get under 30% for this. If it was 330 out of 100, so it's 0.33 and less, and hopefully it is, then we're doing okay, because we do have that friction, and it's going to cause error. But that's what we're trying to get. And it really comes down to not necessarily how we did the lab. It really comes down to how our pulley is. There's nothing we can do about that. That's an uncontrollable error in the lab, and that happens with lab design and equipment sometimes. All right, but we expect it to be higher, so we can conclude, if we do get into 0.3 somethings, we can conclude that, yeah, Newton, pretty smart cookie he was, and his law is correct. We just have to account for that friction. Can we eliminate that friction? You can never eliminate friction completely, unless you're in a vacuum and you're falling. Okay, I'm not talking about a Hoover vacuum. You clean it in the house. No, we're talking about a vacuum like in space. Okay, so you're gonna graph, it says down here, calculate the percent error. Right there on that graph. Oh, it says use 0.2. Don't use 0.2. I use 0.3. I put two masses that equal 100 grams onto that cart. So don't use 0.2. I used a cart which was 0.3. I know it says that there, but I did not do that. Okay? Hopefully you're listening at this point, not falling asleep, or cut the video off, because you're not going to know that. You're going to go, why? Blah, 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 blah. It's a huge error. But you didn't pay attention. All right, last but not least, you have the data table, you have the calculations table, you have the graph you've constructed with the calculations on the graph, and last but not least, those four things so far, and the last thing you need to do to hand in this lab report is to answer those three questions. Answer those three questions, and that's it, okay? So you've got two tables, one data, one calculation, one graph with some calculations on the graph, and answer those three questions. That's your lab report. Partner, this one took a little while. I mean, this one was a little more involved than the other two, especially since I was without you. It was hard to do this without you. I really miss you. I do. I really miss you, lab partner. I hope you're back soon. That's it. That's the lab for the Force Lab. And okay, all right. Well, we'll see you soon.